Hi everyone, in this video I'd like to talk about onto and one-to-one functions. So we'll start with onto. A function is called onto or surjective if and only if it hits every element in the codomain. So as a reminder, our starting set or our input set is called the domain, and then the target space or the set of possible outputs is called the codomain. So in example 1, we have element 1 mapping to X, we have element 2 mapping to X, and we have element 3 mapping to Z. This would not be onto. And the reason it's not onto is because the Y was left out. We didn't hit Y. In other words, we did not cover the codomain. We didn't map to all of the elements in the codomain. We didn't map onto all of the elements. So some important pieces of notation to note here. You would say that the set of elements in the domain would be 1, 2, and 3. The codomain is the set X, Y, Z. And then the range is actually the set of outputs that we get, and the range, the elements that we do land on, it's just X and Z. Okay, let's do one more example. So suppose I had a different example here. I will give you a domain. I'll make it a smaller example. I'll just put 2 elements in the domain. I'll put 2 elements over here in the range, and suppose my function does something like this. This is onto because I've hit all the elements in the codomain. I've covered my codomain. You know, it's like if you were going to make an app, like a maps, you know, a little app for the phones, and so people could use these maps and go drive around, like Google Maps or Apple Maps. You would want it to map onto an entire city so that the user of the app could go anywhere. You would want them to be able to type in, you know, Applebee's, and they could drive to Applebee's. You wouldn't want to have dark spots or places that you couldn't hit with your app. So that's an idea of onto. You want to go cover onto the codomain. You want to be able to hit everybody. All right, so now let's take a look at a slightly different characteristic, and this is going to be a discussion of one-to-one functions. Okay, so a function is 1 to 1, and I've abbreviated that with the little number 1 to 1. A function is 1 to 1 if and only if there are no collisions in the codomain. So let's take a look at an example here. So suppose I have elements A and B in my domain, and now I apply a function called f. So I'll say f is my function, and I'm going to take A and I'm going to f it. Okay, and what is that going to give me? It's going to give me f of A. And now let's suppose I take my element B and I apply function f, whatever the f rule says. It might be square root, it might be, you know, what's your height, what's your weight, if there are people, who knows what the function does. But just abstractly, we're going to f it. We're going to apply function f. So f of b is going to give me f of b. So in this case, this is an example that is 1 to 1. There are no collisions over here in the codomain. In contrast, if I had something like the following, here's A and here's B. Suppose they mapped to the same element. So when I apply f to A, I land over here and I get f of A. And suppose that's the same exact value I get when I apply function f to b. And so a good example of that, if you're kind of wondering, you want to work with some numbers, the rule f of x equals x squared. This is one of these functions. You put in a -1 and you get out a -1 squared, which is 1. And you put in f of 1, you f it to 1, and you get 1 squared, which is 1. So you get different inputs landing on the same value in the codomain. You get a collision. So we have a collision over here, which is pretty bad. We have a collision in the codomain, and so this means it's not 1 to 1. There's another word for 1 to 1. It's called injective. So sometimes you'll see this word injective. Sounds like an injection or something, like a vaccine. I guess it's COVID and all the flu vaccines. These are things that are on my mind. So I think about vaccines, and I think about these pointy needles, that the pharmacist will give you. This a bad drawing of an injection. But if you think about an injection, and this is just injecting right over like a vaccine tube, that's one way you can visualize it's injecting right over. There's no collisions in the codomain. So that's what we mean by 1 to 1.